Okay, right. Um, so we did what we just, this is the last video. What we did was we had, what you saw me doing earlier on in the previous video was this TYU. So you can play with that again just to get comfortable. These are just some questions that you will see that kind of help you further understand what's going on. Remember, this relationship is very much between average time and number of units, cumulative units. So what we see here is this question that says, you got this average unit times for product X have been tabulated as follows, and they're asking what the learning curve rate is. And so what you have here again is this 1, 2, 4, 8 scenario, and then of course you have this. So really, like I said, the learning rate is like we've discussed is the percentage. So for example, there is a certain learning rate of 20 minutes. So the learning rate times 20 minutes gives us what's going on here, 17.2. And then that same learning rate times 17.2 gives us this. So really, I'm just going to call my learning rate, for example, I'm just going to call it Y. Well, maybe Y is not the best because we already have the Y is equal to, I'm just going to call it, well, I don't know, V, for example, right? So I know that 17.2 minutes is equal to V percent times 20 minutes. That's what the learning rate says. This falls by this fixed learning rate. So that means that V percent is equal to 17.2 over 20. And when you do 17.2 over 20, 17.2 divided by 20, you get 0.86. So in effect, that's 86%. So the learning rate is 86%. I can test it. You do 86% of that, do 86% of 17.2 times 17.2, and you get 14.792. And you do 86% of that, 86% of that, and you get 12.72. So it's very clear that the learning rate is 86. So you can get questions like this. So it's just about being flexible, because if you know what you're doing, then you can find the relationship. Look at this one. So this is they like to throw this, so you have to just be very careful. Remember, it's about cumulative average. It's about average. But the time taken to produce the first unit was 100 hours, if you like. So unit 1 was 100 hours, and the time taken to produce the second unit was 90 hours. So really, what that means, if you like, is that the total time to produce the first unit was 100 hours, and so the average is 100. Now, if the time taken to produce the first unit was 100 and the time taken to produce was 90, that means the time taken to produce the total time to produce the first two units must have been 100 plus 90, which is equal to 190, right? So it means that the average time to produce two units must be 190 over 2, and that is 95. This relationship, this learning curve rate, is between average, cumulative average, and if you like, the accumulation of the number of hours. So it's really be careful not to kind of take that individual time, right? That's not how it works. It's about finding what the average is. So now I can sort of see here that the learning rate must have been 95% of the initial. It's always about 95% of that. It's always about the average. That's the thing. So the learning rate here is 95%. Really watch out for that and be careful. And this is the last one I'll do because it's a long one, but it's intuitive. You almost have to kind of work with it to find out what's going on. But pause the video, have a go, but you can then come back and see what what I'm trying to do. So here you can see here that the time taken to produce the first 50 batches, the first batch of 50 units. So really, it doesn't really matter. The key point is that it's the first batch, and the first batch it took you 500 hours, right? So they now tell you that the total time takes is 5731. That's just by the way. Let me find, what I need to do is find the average time it takes to make 16 batches, because they're asking for the learning rate. I don't know it. I can't use the equation y is equal to ax, if you like. Um, um, Interesting. Actually, I could. Let's see. I mean, because I did this practically. I did it using the. Let me just see if I can. I mean, I probably could. So the average time here would have been, or do I don't have the average time, the first 16 batches, 5, 3, in fact, you know what I'm going to do? I'm going to do this both ways. 5731 divided by 16 is 358. I'm going to do this both ways. Sorry, this video might end up being long because I want to do it, and it's a good way of testing it. But let me make it practical, you see, because what happened was when I saw 16 units, I sort of knew that, okay, well, I know that I can sort of create a table and I can say, and if I do this using the formula, that would be amazing. So you can ignore all of this. But when I did this, I actually did it like this. I said, well, I know that the learning rate is the average time to make the second unit is the learning rate times the previous. So I'll just call it V. So that's V times 500, right? I mean, that's what it is. That's the learning rate. And I know, therefore, for 4 units, it must be V times, of course, V times 500. I mean, this here is V times 500, so this would be V times this, right? Which is up here. And I know this will be V times V times V times 500. And I know that this will be, therefore, V raised to the power of 4 times 500, if you like. So this is, if you like, the average time it takes to make 16 units. And so I know what the total time is. So if this is the average time, if you like, the total time, of course, must be 16 times V raised to the power of 4 times 500. I know that total time is given to me as 5731, because this was how I did this, because this number made sense. But I'm going to do it the other way and test it. So it means, therefore, that V4, right, of V raised to the power of 4 must be 5731 divided by, of course, 16 times 500. I guess if you're, again, like I say, the more flexible you are, if you understand what you're doing, you can just be comfortable and get on applying or looking for the different ways of finding this. So V4 happens to be 0.716375. So the question is, I'm looking for V. So therefore, V must be to the fourth root. Take 0.716375 to the fourth root. It's like saying 2 squared is equal to 4. And if I don't know if I'm trying to find, if I didn't know this, if I said x squared was equal to 4, I would say, well, find the square root of 4, right? The square root of 4 is just and I can do it like anything. 27, x raised to the power of 3 is equal to 27. So I know this is 3 times 3 times 3. So I'll just take 27 to the third root. And the same thing can apply. So the key point is I just need to define this to the fourth root. So really, let me just use my calculator on the screen. Again, here I need to find 0.71. Keep 7163 to the fourth root. Calculator. Oops, sorry. Yeah, let's do that here. Calculator. Yeah, scientific. So I have here, you just need to find, yeah, here we are. So you should be able to find, oh, goodness me. It's just finding it, isn't it, on your calculator to the fourth roots. But again, I think it's just finding it on your calculator. But let me just sort of, so here I have 0.716375. It doesn't seem immediately obvious, so I'm going to have to sort of play a little math game here and kind of raise it to the fraction. Let me see, 1 divided by 4. And I don't know if that would work. No, I think it's not. Let me just, wait a minute. I think I know what doing. It's just, again, like I say, it's just getting your calculator. Let me just see, 0.716375. Let's see if I click second degree first. Here we are. That's what I need to. It's just finding it, isn't it? It's just amazing how you have to look for these things. So now I can then click on this and write 4. So basically, I've found that, and you see I have here 91.9. So that's that's equal to 91.9. So the key point here is it's finding the root, and your calculator might just have a nice little button where you can do it. So here your answer is 91. You can see there 0.91, which is in effect 91.9. 9. It's actually 92, I imagine, I suspect, is where I'm trying to go. And so my learning rate therefore becomes 92%. Um, I suppose you could, I mean, what I would have wanted to test is really um, to see if I could have used the um, equation y is equal to, because in my mind, I imagine this must be y, 358.18 is equal to a. I know how long it takes to make the first unit, if you like. I mean, I'm told to make the first unit took 500 hours. So I should be able to sort of say 500 times it's the first 16 batches, 16 raised to the power of of b, but then b is equal to, again, the log. Yeah, it's slightly long-winded. The log of this thing, x, I don't know what it is, and I could find, you can see where I'm going. I could sort of do all of this. So 358, I mean, let's just do it, just because, sorry, like I say, just seeing both methods and just playing with your maths. 358.18 divided by 500 is 0.71. So basically I divide both sides by 500 because I'm trying to isolate this. And so I have 0.716, exactly same thing actually, is equal to 16 raised to the power of b. Well, yeah. So let me, is equal to 16 raised to the power of b. So right, what I need to do is I need to find this. Yeah, so what I guess I'll just say b. So what I'll first of all do is to um, I'm just trying to work out how I would have to do it here. It's more a math issue here. So 16 raised to the power of b is equal to 0.71 um, 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 636. And this is what I need. I need to find b. So that's the bit that I'm slightly, from a math point of view, slightly just stuck on. But I can see, I mean, it's very doable. I just need to get my calculator out and see how one plays with that. So really, B, yes, it's really. I can imagine this is going to be very interesting. I don't think, 16 raised to the. I don't think this is the best way to do this. Let's put it that way. 636. Because what I have to do, technically, from a math point of view, yeah, I think this is the best way to do this, would be, which is possible, is to take the log, to find the log of 16 for both, multiply both by the log of 16, and then find b. But that's too much. I suspect the best way to do this is to do this like I did it the first time. And maybe when we were in class, we could try it this way. And for those of you who might be slightly more mathy, have a go playing with it this way. But yeah, so do it this way and you should be able to find your answer. And let's see what we see in the questions, if we see any that require us to find it like this. There are, but they'll give you a bit of information to do it. Okay, great stuff. And that's the end of this video. No, sorry, let me just finish off. So really, again, what are the applications here? Well, pricing. We can really see what's going on with pricing now. If we know, right, that typically we base pricing on our variable costs, but we can see the variable costs are falling gradually. So it means that we should be sort of comforted by the fact that we can drop price knowing the variable costs are falling. Right, variable costs are falling, and then we can maybe increase price later. But the point is that we know that, of course, that we don't have to, we're not stuck with this idea that variable costs are fixed anymore, and we can manipulate our prices to take advantage of that, of course. And typically, really, we can make as much as really just watching the factors. We now know very clearly that typically our standard costs might need to be adjusted because, again, that old school knowledge of that variable costs are fixed, and when I say fixed, the constant is not quite true. And then you can really apply the marginal revenue, marginal costing concept, and then you can apply that and factor that into your budgeting, budgeting. And of course, the labor budget may be reduced by the learning effect. The learning effect will only apply for a certain range. And after a certain time, we get to a steady state. And once we get to that steady state, there is no more learning. So literally the time it takes to make the last unit just before it learning, so for example, if learning stopped at unit 20 and we find the time it takes to make the 20th unit, that is what will apply to every other unit afterwards. The time it takes to make unit 21, 22, it's just the same time it took to make unit 20 because the learning stopped here. So it's just that exact same time it took. So you would almost start looking at it from that point of view from there, which is what I was saying in terms of application. Okay, great stuff. So I will make one more video just to look at TYU4 in terms of understanding this issue of the steady state of what happens just at that point once we get to the point where we've stopped learning and we're literally just using and doing exactly the same time. Okay, great stuff. See you in the next final video.